And this is connected to this. Okay, great. Well, these are model qubits. Okay, you can hold one if you like. And so to perform a measurement on this qubit, you shake like a little jab in the direction on which you'd like to measure. For example, I can measure in the z basis by shaking on the z-axis. Right? Yes, exactly. Right? Exactly. And so you got 0. And you can also shake in any axis, just like you can measure a qubit in any basis. So, for example, I'm doing an x measurement, I'm doing a z measurement, I'm doing a y measurement, right? Yes, fantastic.
Cool.
We can also entangle them together by bumping them. So now they're entangled, and now
I can measure,
yes, you can
destroy
measure
one and...
try it. Yes.
Oh.
And so you got somewhere on the top, and I got somewhere on the bottom. And we can do that as many times as we like to try to figure out which state this is. So I can tell you this is one of the Bell states, one of the 4 Bell states. And our goal is to figure out which Bell state it is. So I just measured in the x basis, and we got opposite results. And maybe we can measure in the y basis as well.
Yeah.
And we got opposite results, right? And so this happens to be the state in which all 3 axes, x, y, and z, are opposite parity, which is the signal state, right? There's many other things you can do, like you can do any circuit that you'd like. Like I can measure these out, so you see that if I do an x gate here on that one, yes, you can do a C0 as well. So I can do an x gate on mine. We can do, let's start here. Let's start both on the bottom. Let's do a Hadamard on yours. And then let's do a C0. I tap once and I define the control. And I tap again and I define the target. And so now we get to the Bell plus state. And now if I measure, of course, I'm going to get the same result on the Z basis. Right?
Cool.
So you can do anything. All of quantum computation, you can do up to 5 qubits. Yeah.
And if I hold it wrong and bump it, it will not?
It should bump.
It finds the top. So it doesn't matter how to hold it initially. Yeah, like
it doesn't matter.
It has an gyroscope and magnetic field for
mainly accelerometer. So it detects the direction of your shape, x, y, z. Yes. Actually enacts the X gate. So as your laser is moving or turned on, the state will continue to process. And usually we might want to do the X gate, right? So your goal in this game is to get as close to an X gate as possible. I know that it started at the bottom, so the goal is to get it to the top. And so I can show you, like, I want to stop it, I want to end the laser, like, close to when I get to the top.
Yeah, and then it's a
good
result.
fidelity.
Yeah, 97% fidelity.
Yes, yes. And so we have a leaderboard.
Cool. So you switch off laser.
Yes. Okay, 98. Not bad. You get 3 tries. The goal is to get to 3 nines of fidelity.
3 nines.
So yeah,
impossible.
Try, yeah.
Should be slower speed.
Okay,
almost.
Okay, close. You get one more try. 8 happen. And so if I stop it at some point, you'll get some. I got 99.2 fidelity. And then we also have this state unscrambler game, which is out of many games. Your goal is to get this state to the bottom. And you have these gates. You can drag them onto the circuit. And so the goal is to run this circuit and get this state to the bottom. Right? So the first one is super simple. But yeah, you can maybe try
and it does not matter where to place it.
Yeah, it doesn't matter, yeah. But once there's more gates, right?
And then it's like 10 and...
This is the minus state? Yes, this is the minus state, yes.
It then matters which is first and which is second, in order matters, right?
Yes,
yeah?
Yes.
I don't know. Това е така Massive, never surprised.